Welcome to the video for page 5 of the mat050 Final Review Study Guide. Page 5 starts with question number 12, although I can see here that something happened and number 12 ended up starting on page 4. I didn't page 5. So question number 12, the population of Westminster, Colorado was 109,169 in 2012. So if the population increases by 2% of the previous year's population, not 2% of the current population, but the previous year's population, use this information to fill in the table. So after 1 year, I will take the 109,169, and that's going to increase by 2%. So it's going to increase by 2 out of 100. And I'm going to do that on the calculator. So 109,69 times 2 divided by 100. If you want, you could do 0.02, but I'm going to do it this way. So it's going to increase by 2,183. So 2,183. And hopefully it's obvious that I'm rounding to the nearest person. So it's going to increase by that. So I'm actually going to have 109,169 plus 2,183. And I can do that on the calculator. Plus 109,169 equals 111,352. Actually, 353. 2. 111,352. So I can put that in my table. And the second year is going to increase 2% of not 109,169. It's going to be 2% of 111,352 times 2 divided by 100. And I'm going to, actually this time I'm going to do it all in one step. So I'm going to say 111,352 and I'm going to add to that 111,352 times 2 over 100. And I'm going to put that in my calculator, see what it equals. I don't have room to write it, but I'm going to put it in my calculator. And I'm on scientific notation. So I got my 111,352. Already got that in there. So I'm going to say plus 111,352 times 2 divided by 100. And you'll notice my calculator is doing PEMDAS. It's putting the equation in and it's doing the multiplication before it does the addition. Sorry, it did not. Let me do that again. So I'll have to do parentheses now. 111,352. That's why we have to think about math. We don't always, calculators don't always do what we think they will. So plus 11,000. Since I knew about what I needed, I knew something was wrong. And what I need to do is put parentheses around my multiplication and division. 111,352 times 2 divided by 100. I'll close the parentheses. That gives me 2,227. And that's what I'm going to add instead of the 2,183. I don't add the same thing every time. So I add that and I get 113,579. $579. So that's what I'm going to take for my next year. And this time I'm going to notice I could factor out that 113,579. And I'm going to say that's times 1. I can do that. You may not see why, and hopefully see in a moment, but I'm sure everyone agrees I can do that. And then I'm going to say this is 113,579 times 2 over 100. I'm going to see what that equals, but before I do that, I'm going to factor that 1,579 out. Sorry, 113,579. I'm going to factor that out. I'm going to say that's times 1 plus 2 over 100, which is the same as 1.02. 1 plus 2 over 100 is 1.02. So I'm going to go back to my calculator now, and this time I'm just going to take this number and say times 1.02. It gives me 115,851. So I write that in here, 115,851. I could have gone on just doing exactly what I did for the first one, multiplying by 2 over 100, adding it, multiply that number times 2 over 100, add it. But now I found that every time I can just multiply by 1.02. So to get the next one, I'm going to say times 1.02. I get 118,168. So after 5 years, I'm going to multiply by 118,000. Sorry, I'm going to multiply again by 1.02. I'm going to multiply 118,168 times 1.02. I get 120,531. 120,531. So that kind of helps me with question B, Question B says, what formula would need to be typed into cell B7 in order to calculate the population after 6 years? I can just take B6 and I start with an equal sign because Excel won't do a formula unless you start with an equal sign. The equal sign says make this cell equal to the answer to this calculation. The calculation I want to do is cell B6 times, and Excel, we always have to put a star. You can't just put things next to each other. We always have to put a star, times 1.02. In question C, assuming the trend continues, show the numerical calculation to determine the population after 20 years. And if you'll notice, I started out showing how to do the calculation the long way, just so you could see the thought process. But I could have just multiplied by 1.02 every time. If I take 109,169. Let me just start over. Let me do that. 109,000. 109,169. If I multiply that by 1.02, I missed the 2,183, but I get the 111,352 that I would have gotten after I added. So I could have gotten the same answer for the first one if I had just multiplied by 1.02. So the lesson there is, for every year, we multiply by 1.02. We take the current population, and for every year, we multiply by 1.02. So I take my current population, 109,169, and I'm going to multiply it by 1.02 for every year. So I'm actually going to multiply by 20 1.02s, and I can do that with exponents. I don't have to write 20 1.02s. I can just say times 1.02 to the 20th power. And question then says, then calculate the population. So show the numerical calculation. I've done that. Then we actually have to do the calculation. And if you remember on the test, you have to do both. You have to show the calculations and you have to show your answer. So for my answer, 109,169. And I'm going to say times. I'm going to use parentheses, 1.02, just because I'm not super confident in the way the calculator's working. And I want to raise it to a power. And if you'll notice this button here, it has an X and then a little Y above it. That's telling me I'm going to take the number in the register and raise it to the next power. And you see the caret there. It's asking for an exponent. My exponent is 20. I'm going to close my parentheses now. And that gives me raising 1.02 to the 20th power gives me 1.4859. And when I push equals, it's going to multiply that by 109,000. And it gives me, after 20 years, 162,219. 160,219. And I'm sure you'll agree it's a lot simpler to do that than to keep adding 2% every time. And the main thing I want you to see, the most important thing, is that you do not add 2,183 each time. And that's because of this, 2% of the previous year's population. So it adds 2% of the population from the year before, not 2% of the 109,169. Take a quick look now at question 13. Pause the video for a moment, and when you think you have a good answer to question 13, come back and see if you agree with me. Okay, question 13, now that you've looked at it. A Lamborghini can reach incredible speeds. One driver demonstrated this by hitting 250 miles per hour in a 1-mile race, but his engine went up in flames as he crossed the finish line. How fast was he going in feet per second? Round to the nearest hundredth. I'm going to think about this. I need to change miles to feet, and I need to change hours to seconds. And I'm going to do that this way. I'm going to write my 250, and I'm going to say MI. MI is miles, M is meters, MIN is minutes, miles per hour. And I'm going to work with the hours first. I have 60 hours, and I know there is 1 hour in 60 minutes. Okay. And my hours will cancel. I'll do that later. I'll show you that later. But I don't want miles per minute. I want feet per second. So I'm going to change to seconds next. I know there is 1 minute in 60 seconds. So my hours cancel, my minutes cancel. I have miles per second now. I want to change miles to feet. So now I know there's 5,280 feet per 1 mile. And if I take a look at this now, there we go. My feet cancel. I'm sorry. My miles cancel. My hours cancel. My minutes cancel. And I'm left with feet per second. So I have, and I'm going to go to my calculator again, 250. Let's do the division. Divided by 60, divided by 60, and times 5,280. And I get 367 feet per second. Take a look at question 14 now. Pause the video. When you think you have an answer, come back and see if you agree with me. Okay, now that you've paused the video and looked at question 14, hopefully you got something similar to what I'm about to do. At Sam's Club, you can buy 10.5 pounds of baby back ribs for $68.25. County Market has a sale on their baby back ribs, which reads 3 pounds for $19. Find the unit price for each type of ribs and use it to determine the best deal. If I want to compare things, I want to know how much things cost per pound. If I want 10.5 pounds of baby back ribs, I can get it for $68.25. But I could get 9 pounds for 3 times $19 at County Market. Or I could get 12 pounds for 4 times $19. Question is, how much am I paying per pound for each one? That tells me which one gives me the better deal. So I'm going to go so I'm going to see how much is in 1 pound. So in order to do that, I need to take the 68.25 and I need to divide that up into the 10.5 pounds. How much of that 68.25 am I paying for each pound? I'll go to my calculator. 68.25 68.25 divided by 10.5, 6.5. So I end up with 6.5. This is dollars per pound. So I'll say dollars per pound. I'm going to do the same thing with the information for county market. So I go $19 per 3 pounds, or divided by 3 pounds. I'm going to divide that $19 into the 3 pounds. And so once again, take my $19, divide by 3 pounds. I'll get 6.33. And I'm going to round it to 2 places because that's how money works. 6.33 dollars per pound. So now I'm going to say county market has the better deal. And don't just write county market. You want to write county market has the better deal, but you don't need to watch me writing that. So let's take a look at page 6 now. See if you have questions on that. Then go to the video for page 6.